All right, Algebra 2, welcome to your second Chapter 3, Part 1 game plan video. This is for Friday the 15th, the second day I will be gone. We are on page 4 of your game plan. We are sponsorless, but our in-house studio audience still here, like we're prepping for Toy Story 5. All right, Stuart the Minion holding it down as our #1 teaching assistant. This page technically says hashtag game time, so I'm going to do most of these with you. Now, I will say something like 17. Look at 17. You're going to use substitution on 17. You know exactly what y is, so you're going to take this and plug it in for y right there. Negative 3x plus 4 times 2x minus 5 is equal to 0. You're going to solve for x. Whatever x is, you plug that in. Top equation. Let's do 18 together. As we know, you have the same sign, 6x and 6x. How do I make a 6x and 6x turn into 0? Well, I subtract them. 6x minus 6x is 0. Negative 5y minus 2y is a negative 7y. 14 minus 31 is a negative, or I'm sorry, 17 minus 31 is a negative 14. Divide negative 14 by negative 7, I get a positive 2. I'm going to take that 2, I'm going to plug it in either there or there for y. I chose the bottom equation. Plug 2 in for y, I get 6x plus 2 times 2 is 31. X is 4.5. All right, let's do 19. 19, I tripled the bottom equation. Doesn't matter if you want to get rid of x or y. You would triple negative 3y to get negative 9y. Now the y's are opposites. You would triple a negative x to get a negative 3x. Now the x's are opposite. So it doesn't matter if you want to get rid of y or x. They're opposites, so we're going to add the equations together. Get 0 on the left side equals, look at that, 18, negative 18. Those are opposites. That's a true statement. So all real numbers, you can make the r with a line, an extra line. That's all real numbers. Or you can write out all real numbers or infinite solutions. But that special r means all real numbers. This next one, what did we do? We multiplied the top equation by 4. 32x plus 12y is equal to 48. The x's are opposite, the y's are opposites. Add them together, you get 0 equals 96, which is false. That's no solution. All right. Let's take a look at 21. I want to get rid of the y's because they have opposite signs. Hence why I multiply the top equation by 4, the bottom one by 5. If you want to get rid of the x's and multiply the top one by 2, bottom one by 3, that's fine. You're just going to have to subtract the two equations and not add them together. In fact, that is what I did over here. So we'll do it both ways. So first, if I multiply the top one by 4, top equation by 4, the bottom one by 5, my y's are opposites. Now I can add the two equations together, get 22x equals 77. X is 3.5. Then I'm going to take that 3.5 and plug it in for x in the bottom equation, so I don't have to deal with decimals. 2 times what x is, minus 4y is equal to 1. You can see how I solve that. I got x or y is 1.5. Now again, if I want to take the top equation multiplied by 2, bottom equation multiplied by 3, then I'm over here. 6x and 6x become 0 through subtraction, so 10 minus a negative 12y, that's 22y, equals 33. Y is 1.5. Take that 1.5 and I plug it in for y in the second equation. That's 6 to both sides divided by 2. X is 3.5. So it's up to you on 22 what you want to solve for. Maybe let's multiply the top one by 5, the bottom one by 3. So now the x will match up. Okay. You can't really see any of that. Now the x's match up. I want to get rid of the x's through subtraction. You can get 2y equals negative 65 minus a negative 57 is a negative 8. Y equals negative 4. Take that negative 4 and plug it in for y somewhere, either there or there. You can finish that one. Make sure you get x. That's page 4. We're going to do a few here on page 5, then I'll come back and help you when we meet again. On 23, you're going to double the top equation. Now I get 6x plus 2y is equal to negative 4. Doesn't matter if you want to get rid of x or y. You're going to need to subtract 0, because you have 0x and a 0y is equal to negative 4 minus 10 is a negative 14. That's a false statement. This one has no solution. On 24, I need to get rid of that 1/2. I'm going to double that equation. 4x plus y is equal to negative 2. You have 4x plus y is equal to negative 2. It's the same equation twice. Hence, when you subtract, you're left with 0 equals 0. That's a true statement. If you have the same equation twice, that's the same line. You always have all real numbers on that, Kate, in that situation. All right, here is a word problem we can do together. 2 welders worked a total of 48 hours on a project. One welder made $32 an hour. That person's going to be X, while the other made $41 an hour. That's going to be Y. If the gross earnings for the 2 welders was that much money, that's how much you paid for labor, how many hours did each welder work? Well, X is going to be the welder. How many hours the welder that made $32 an hour worked? And Y is going to be how many hours the welder that made $41 an hour worked. I know that in total they worked 48 hours, so X plus Y is 48. That's my first equation. My second equation is for every hour that X worked, made $32, plus for every hour that Y worked, made $41. And in total, that was $1,734. Now what I did is I took this equation 1 and I said, let's get rid of the X's. So let's multiply this equation by 32. Let's take this equation and multiply it by 32. 32X plus 32Y is equal to 48 times 32. That number. Now I can get rid of the x's if I subtract. 32 minus 32 is 0. 41 minus 32 is 9y is equal to 198. Y is 22. So if x plus y is equal to 48, then x plus 22 is equal to 48. X is 26. 22 hours for the person that made 41 an hour and 26 hours for the person that made 32 an hour. All right. That is page 5. The rest of 5 we will do together. Let's go to page 8. And again on page 8, we've got some hashtag game time. On 1 through 8, solve each equation, solve each system. This is a clear-cut example of substitution. I'm going to take x minus 2, and I'm going to substitute that in for y. So 2x plus what I'm plugging in for y, which is x minus 2. It's equal to 19. 3x minus 2 is 19. 3x is 21. X would be 7. I'm going to take that 7 and plug it in for x right there. Y is 7 minus 2. Y is 5. All right, I'm going to help you out with 2 because I made a boo-boo on 2. There is a typo there. All right, what do you want to get rid of on number 5 here? Do you want to get rid of the x's or the y's? You have opposite signs, so both are good choices. What I did here is I got rid of the y's by multiplying this top equation by 3, this bottom equation by 8. Again, positive 3, positive 8. If I multiply the top equation by 3, I have a negative 21x plus 24y is equal to negative 30. If I multiply the bottom equation by 8, I have 32x minus 24y is equal to 96. The y's are opposite signs, so I add them together. Bye bye y. I have 11x is equal to negative 30 plus 96 is 66. X is 6. So I'm going to take that 6. I'm going to plug it in for x right there. Negative 7 times 6 plus 8y is equal to negative 10. Y is 4. Take a look at 6. Again, these are going to become much easier after we handle the 3x3 system. So you might take a little bit of a bruising right now, but after we work with the 3x3s when I get back, these 2x2s are going to become a lot easier. I want to get rid of the x's. If I double this equation, I will get a negative 4x. So I take equation 1 and I double it. Now my x's are opposite, so I add the two equations together. I get a negative 5y is equal to 40. Y is equal to negative 8. I'm going to take this negative 8. I'm going to plug it in for y right there. Add 8 to both sides. X is 5. Numbers 3 and 7 are special. Number 3, I'm going to double the first equation. I have the same equation twice. When I subtract the second equation from the first equation, I get 0 equals 0. That's a true statement, all real numbers. So this is your actual answer, all real numbers. On 7, they are already opposites, so I add them up. I get 0 equals a negative 9. That's false. No solution. Got parallel lines. On 4, we got substitution. If you have a variable all by itself, you're going to plug this in for x in that first equation. So 6 times what x is 5 minus 3y. Minus 5y is equal to 53. 30 minus 18y minus 5y is equal to 53. 30, combine like terms, minus 23y is equal to 53. Subtract 30 from both sides, divide by negative 23. Y is a negative 1. If y is a negative 1, plug negative 1 in for x right there. 5 minus 3 times the negative 1. There you go. All right, you can handle 8. If you want to get rid of x, multiply top one by 5, bottom one by 3. If you want to get rid of y, you can multiply top one by 6, bottom one by 4, or top one by 3, bottom one by 2. And in this video, the last page for today, going to be page 9. Solve the following systems of equations by graphing. So this first one in black, slope, so y-intercept is 3. You're going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Keep doing that. Second equation has a y-intercept of negative 2. Dot there, then you go up 1 over 2. Ding, ding, ding. Make sure you show that you have a straight line going through both. Draw the arrows, and they intersect at 2, negative 1. All right. That's graph number 2. First one here is a y-intercept of 5. Then you're going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Second one has a y-intercept of negative 3 and a slope of 3, up 3 over 1, up 3 over 1. Ding, ding, ding. They intersect right there at 2, 3. All right, number 3 is about the easiest. In fact, you've already seen this one. Easiest you can have here. They both equal y, so they both must equal each other. That's the 5x minus 2 equals negative 4x plus 16. That is, add 4y to both sides, add 2 to both sides. You're going to get 9x is equal to 18. X is 2. Plug 2 in for x there or there, and you get y is 8. And lastly, number 4. The x's are the same sign, so subtract. X minus x, 0. 3y minus a negative 2y is 5y. And 10 minus a negative 15 is 25. Y is 5. I'm going to plug 5 in for x right there, or y right there. X plus 15 is 10. X is a negative 5. Oh, I wrote my answer wrong. Your answer should be negative 5, comma 5. All right, I think that is good for this video here on Friday. All right, folks, that is it. So you have another video for Monday, then I should hopefully see you on Tuesday, and we'll continue with that. All right, folks, this is Yak Math Videos signing out.